All right, let's start. So, let me give you a 30-second introduction of Prodia, since we're going to use it for a demo today. So Prodia is a DAS tool, so Dynamic Application Security Testing tool. It's basically a scanner that, given the URL of a web application or API, through HTTP, it crawls the web app or the API and injects malicious payloads on every injection point of the web app or API, and then analyzes the behavior of the application faced with those injections. And based on that, it determines if it's vulnerable to a certain type of vulnerability or not. So we built Prodia to be very DevOps centric. We follow from the beginning an API first development approach, meaning that everything that you see on our interface is available through an API. It's documented in an API. The documentation is available at developers.prodia.com. We only provide relevant findings. I can share with you that our false positive rate last year was 0.07%. We do several things in order to prevent reporting false positives, such as safely exploiting the vulnerability in order to gather an evidence that the vulnerability is real. We are able to scan any API or web app, including single-page applications, so JavaScript, rich applications. We have a very top-notch next-generation crawler to be able to render those JavaScript applications in the browser and still find all the sections of the application to scan. And that's pretty much what Prodia does. So this is going to be our agenda for today. First, we're going to discuss why API security in first place. And then the rest of the presentation is pretty much going to be focused on scanning APIs, on performing security testing on APIs. We'll start off with some requirements and some prep work before you start scanning, and then we'll dive into a demo. So why API security? More and more companies today are building and using APIs more than ever these days. It's been a hot topic since 2019, I believe, with the release of API Security Top 10 in 2019, it boosts the interest for API security. And when you look at the risks exposed here, these top 10 risks, a lot of them are complex to mitigate. And it's very frequent to see in the news stories about API security, breaches that happened, and how much this is costing to businesses today. So let's analyze one of the top risks from the WASP API Top 10, the second one, broken user authentication. When you look at API and the way you interact with APIs, there's usually three different scenarios. One of them is the computer program to API. It's basically when you have a developer that builds a program or script that interacts with another API. That API can be internal or a third party. And when you look at authentication, the usage of a secret static key or token is very popular and frequent. So now let's look at the second type here of interaction. You have an app in your mobile phone that interacts with an API. So the communication here is more between the mobile device and the API server. In terms of authentication, you see a mix of static keys, like in the former case, or dynamic keys. Another type of interaction that is becoming more popular today is when you have a web application, typically a single page application or SPA, interacting with an API. So communication here is between your browser and the API server. And here you mostly see the usage of dynamic keys. Now let's see the challenges from each case. So the typical computer program to API, communication is usually server to server. So it's easier to get authentication right. The popular solution here is to use static keys. Of course, there's some questions that you need to ask yourself. So is this going to be a private API, or it's going to be an open API? You have open to the world for other users to use our API, or if you're just using internally within your organization. When it's a private API, developers often relax on authorization issues because, I mean, it's private, right? It's like only available within your organization or within your team. So you see often that developers relax on authorization issues and other types of issues. When you look at mobile apps that talk to APIs, then if you use static keys, you have a distribution problem, right? So if you, for instance, save a static key within the program itself, within the app itself, in the binary that you distribute, of course, if something goes wrong and you need to revoke that API key, then you need, like to make everyone to install a new version of your app, and that's not going to happen from one day to another. If you use dynamic keys, how are you going to use the dynamic keys? Where are you going to store them? And do you use the key directly on all requests? How long should it last? And one thing that also happens often is that developers also think about this case like a server-to-server case. So the third case, when you have a web application, single-page app, talking to an API. The normal case is usually like you have an authentication, usually with login and password, and then upon a successful authentication, you get a token back, or your web app gets a token back. Where do you store that API key, and how do you protect it? The same questions. How long should it last? Even though developers often see these like a server-to-server communication often, and they try to mimic the static key behavior, they need to keep in mind that all of this is happening in the user's face. It's happening on their browser, right? So it's very easy for a user to see what's happening and to have access to everything, all the source code and everything all the communications that are going on between your web app and your API. Just a tip that I have here. So if you're implementing this case, authentication for this particular case, there's a very good article on Medium, getting token authentication right in a stateless single-page application. If you Google for just the title of this article, you'll find it easily. So now I'm going to share with you some of the things that I've seen in the wild. So all of these are real examples that I've witnessed, or in the first case that I found. I was doing an assessment in a cryptocurrency project, and I cannot tell more than that. But basically, the client was complaining that there were people like basically hijacking users' accounts. And even after they changed the password and everything, the attacker would still have access to the users, to the victims' accounts. And basically, of course, the main goal of the pen test was to find out how. So during the pen test, I found that, well, authentication this was a single-page app talking to an API. The authentication was normal user authentication with username and password. So there was an endpoint on the API to do the authentication. That endpoint returned a static API key to the browser, and that API key was stored in local storage. Okay, so pretty straightforward. Login, user and password. On success, a static key or an API key is returned, and that API key is stored in the local storage of the browser. So then when the user wants to perform some operation, some transactions, something on the site. Basically, there's a call to the API for that operation. And within that request, there's an authorization header with a unique key that is derived from the static key. So basically, that static key that they got previously upon a successful authentication is not used directly on the subsequent requests. They make something, and the static key was actually different per request. So each request that you perform to the API, the static key, the key would be different. Okay. And then later on, I found that there was a cross-site scripting on the site. So picture this attack. So the attacker sends a craft link with a cross-site scripting payload to the victim. The victim clicks on the link, and using the cross-site scripting, you're able to get the key that is stored in the local storage. Pretty easy, right? After you get the key that was stored in the local storage, which is not the key that is used directly in the API operations thereafter, if you create an account on that site and then you do an inspect on your browser and you go to the local storage and you change the static key with the static key of the victim, suddenly you're able to impersonate the victim and do everything that the victim can do. So basically you could do all the operations like if you were the victim. And worse than that, if the victim realized this and changed the password, it wouldn't really matter, because that static key was permanent forever. So as long as the user exists and the account was valid, they used the same static key. So basically what happened here was that API was probably built in first place to be used server to server communication, right? And then they build a web app, a single page app, and that single page app calls an API. Hey, we have a problem. We need to authenticate users. How are we going to do this with API and so forth? So basically they probably came up with their own solution to use the typical static keys that you use from server to server, adapt to this new single page app context. And the main problem here, well, there's a lot of problems, but the main problem here is that that static key is permanent. So if the user changed password and everything, the key remained valid. So basically, you're able to attack and hijack a victim's account by just chaining these broken user authentication with the cross-site scripting. The second case was also a cryptocurrency company. And this is more like facepalm. So basically, it was pretty much the same in the sense that there was a web application talking to an API. So the user would go to the web app, would log in with username and password, and in response, the API would say login successful or not successful. That's it, okay? The web app had some sort of sessions, but then all the calls to the API didn't include any authentication or no authorization header, no cookie or whatsoever. So basically, they assume that, well, the API is not public, right? It's the web app that uses the API, so no one sees this. So basically, they didn't implement any authentication or authorization on the API. So basically, you pass as arguments the user ID, the wallets, and like if you want to sell, how much, and so on, and all good. So basically, any attacker that found this could just, call the API directly, use the user ID of a victim, and perform operations on their behalf. So in this case, it's like what I said, the API is kind of hidden from the user's eyes. It's called by the web app. Of course, everything is in the user's face. It's running in the browser and you have access to everything. So this is pretty much like a big facepalm. So now let's move to scanning or testing the security of APIs. Let's start with some requirements and some prep work before you actually start scanning. So I believe that probably most of you know what Postman is or what OpenAPI or Swagger means, but I have the definition here. So basically, Postman is a tool that is often used by developers to help them building the APIs, testing the APIs. It's a tool that allows you very easily to make requests to the API, see the responses. You can have variables for inputs and so on. And the Swagger or OpenAPI, they're pretty much the same. So the Swagger or the OpenAPI was formerly known as the Swagger specification. It's just a specification or a standard that defines the API, basically all the endpoints that the API has, all the parameters, the types of parameters, the types of inputs, and so on. So first things first, of course, like if we want to scan an API, the first thing we need to ask ourselves is what type of interaction do you have with your API? Is it an API that is consumed by a web app, a single page app? And if it is, does the web app actually covers most of the API in the sense that does the web app calls most of the methods of the functionality of the operations that the API provides or not? So basically, is the coverage good enough for you to use the web app to scan the API or not? Or is your API consumed by a mobile app or a computer program and script? So with Probly, you can scan both cases. You can scan a web app, a single page app that calls an API in the background, and probably by scanning the web app will also scan the API. Or if you want to just scan the API and nothing else, you can use a Postman collection or a Swagger or OpenAPI schema file, so that probably understands how to call the API, the parameters, and so on. So just to explain how this works in high-level terms. So basically, for the scanner, you have two main components, the crawler and the scanner itself. So in the case of a web app, you have the crawler that is basically a headless browser navigating through the entire application. So it renders the JavaScript and so on. It listens for events, clicks on everything, fills out all the forms and so on. So basically the mission of the crawl is to go everywhere within your app. And then as it finds endpoints and sections of the app, it passes them to the scanner, and the scanner will test the security of those endpoints. In the case of API scanning, we also have a special type of crawler that basically makes requests to the API based on that OpenAPI or Swagger schema file, or if you provide a Postman collection file to Probly will also use that Postman collection to understand the endpoints of the API and so forth. And then it's the same thing as it crawls those endpoints, as it makes the valid request to all these endpoints. It passes them to the scanner for the scanner to test. So that's pretty much in high-level terms how this works. So what are the pros and cons of each scenario? So if you're using, or if you have a web application, a single page app that calls an API and the coverage of the API is pretty good from the web app, this is a pretty straightforward way of testing the API with no headaches. And it's probably the most efficient one as well. It's easy because when you're scanning the web app, the API is called by the web app, so it's automatically scanned as well. And there's one interesting feature about this, which is you know that you're making valid requests to the API in first place. So basically, you're using the API in a correct way. You're passing real values for the parameters that are being used when you're calling the endpoints of the API and so forth. Let's say, just give an example. Imagine that the web app has a page for you to see your user profile that makes a call to the API that is like / user details, and then you pass as the parameter the user ID. User ID 1001, for instance. Since the web app is actually making the right calls with the right values, then the scanner will also start off with a correct or a successful request response. And this is important for the scanner because by getting a successful response, that successful response can provide some insights to the scanner. The disadvantage of this is that, of course, a matter of coverage. If the web app doesn't use the majority of the API capabilities, endpoints and operations, then of course it's not enough. The other option that you have is you scan directly the API and just API, provided with a Open API or Swagger schema file. So the advantages of this is that, of course, you have an easy way to tell scanner what are the endpoints and the parameters that API has. So there's no need for crawling like in a web app that you need to render JavaScript and click on things and wait for events and so on. So this is pretty much straightforward. You have like a contract that says this API has this operation, this operation, this operation, and that operation takes as inputs these parameters and so forth. So basically, it's a easy way for Prodia to scan. If the API changes, if the schema changes, you can also tell Prodia to scanner to scan a fresh schema. Basically, it will retrieve a fresh schema before each scan. And for the developer, like providing or making a Open API or Swagger schema file is easy. It often can be generated automatically based on the documentation of the API and the code of the API. On the downside, you have that these schema files are generated by multiple tools and consumed by one tool. So basically what I'm saying here is like, there's a standard involved here. So there's a schema here. And the producer of that schema file, it's a bunch of different tools. It depends. If you use one tool, another user might use a different tool. So you have multiple tools producing these schema files. And the scanner, in this case, probably is the one that is going to parse that schema file. So it's just one tool parsing that schema file. And here you might have some problem because depending on how strict your generator is in terms of the standard, we see often a lot of schema files that don't even pass on those schema parsers that you have available online. So it really depends on the tools that you use and how strict does the generator follow the standard. One other problem has to do with the values for each API endpoint, like I was referring before. Like if you have an API call to fetch the user details where you pass the user ID, if your schema file only says that user ID is an integer, like the scanner or will most likely use 1 to begin with, but 1 might not be a valid user. So you'll get a 404 response. So it's more difficult to get these successful request responses unless you provide some custom values for those parameters probably on the target settings. So this is just for you to see how a schema file looks like. So this is OpenAPI 3. And you can see that this API, one of the paths, so one of the operations is tokens. This is actually the endpoint for authentication. And you can see that there's two parameters. One is username and the other one is password. And both of these parameters, the type of input is a string, and the schema file actually uses an example. So it gives an example, Corinne Le Marchand as the username and 123456 as the password. This is actually from a known testing API for testing purposes. So these are actually valid credentials. Of course, you shouldn't do these in your own API, but using examples for the parameters of each operation is important, because probably we'll use those examples as inputs to those endpoints. One other way to use this is basically on Postman collections, right? So it's likely that your dev team already uses Postman to test API. And when you build a collection on Postman and you export that collection and pass that collection to Prodia will basically run that collection exactly the same way as Postman. One advantage here, unlike in the Swagger file, is that you only have one generator for Postman collection, which is Postman itself. And so there's no compatibility or interoperability issues here, because you have Postman creating the file, the Postman collection, and then you have a tool from Postman on the scanner itself to run that collection. One other advantage here is, like, if you're familiar with Postman, Postman includes pre-request scripts and tests that can gives you more control on the API itself. And we're going to see these in the demo part in a few minutes. One of the disadvantages of using Postman is that everything is set up on Postman. So basically, when you upload a Postman collection on Prodia, there's not really much visibility on Prodia's side on how the API is being tested, because Prodia will just run the collection. So authentication and everything needs to be in the Postman collection. You don't have to configure anything on Prodia's side. So just see here, like, running a Postman collection. So a screenshot of Postman and the result of running a Postman collection. So you can we can see here there's several endpoints, and you can see the success, the HTTP response. So the 201 that basically a token was created, a token was destroyed, and then the result, the success result for each operation. And basically Prodia will run exactly this and then pass to the scanner for the scanner, of course, to inject malicious payloads and test the API. So conclusions before we move on to the demo. You have to decide if you want to scan the API within the context of the web application, or based off of OpenAPI or Swagger schema file or Postman collection. So you have these three options, and you need to decide on which path to follow. If you're using OpenAPI or Postman, make sure you provide real values to the parameters used in API, as I explained before. That successful request response makes a difference to the scanner. And dynamically scanning your API for vulnerabilities using a scanner like Prodia is only one step to make sure your API is secure. Of course, this is not enough. You need to complement it with manual pen testing, with static code analysis tools, SAST scanners, runtime protection tools as well, and so forth. So this is just one step. Don't rely on doing only this to make sure that your API is secure. And that's it. Now let's move on into the demo. So you can see here the interface of Prodia. This is the enterprise version of Prodia. We already have some targets here, but we're going to add a few more targets. first, let's explore a little bit the API that we're going to be testing. And so the API that we're going to be testing is this API called WebShip, which is basically, well, a testing API that has several endpoints. So basically, you have the endpoint to authenticate, which is this token. You have another endpoint to delete authentication tokens, which is this one here. And then you have one basically to get the farmer's farms, to get the farmer details, to update the farmer details, get a list of sheep that the farmers own, and you can also add sheep. So basically, this is an API to manage farms, farmers, and sheep. And we can actually try here so that you see how it works. So like for authentication, we actually use this example here, which is valid. And so we can try it out here. So we're going to pass that username and password. We're going to send the requests. You can see here the request that is being executed. And then the response was a 201. So basically a token was created, and this is the response. So you see here an ID, which is the ID of the token itself, the authorization token itself, and the user ID. So we're going to copy this this authentication token. We're going to copy it, and we're going to use it here on authorize. So, all right. So now we are authenticated. So basically now every call to every single endpoint that we're going to call from now on includes an authorization header with that bearer token. And you're going to see that afterwards. So basically here. So let me just copy here the user ID as well. We're going to need it. Okay, let me close this. So here, get farms. So this takes as input the farmer's ID, which is what I actually just copied. So I'm going to put the farmer ID. Okay, so this is the farmer ID. I'm going to execute. You see the request and response. So this is the response. So this is the farmer ID and the details of the farmer ID. Okay. So this request, you can see here the curl comment to make this request. You see the authorization bearer header with the token that we got from the first step. And then, well, there's no point, but you have more endpoints. This one also takes as input the farmer ID. And this one here, you pass the attributes or for the ship and to add a new ship. And this one just lists the ships from a farmer. So takes as input the farmer ID as well. And here you can see actually the specification of the API, the schema file in OpenAPI, which is basically the screenshot that I showed you before. So let's first use Prodia to scan these API based on these Swagger or schema file. So we're going to go back to Prodia. We're going to click on Add Target. So we just give it a name. Let's say WebShip Swagger. We provide the URL. So this is the base URL of the API. Basically, this is the prefix or the URL that is prefixed on each request. It's the base URL for the API. Here we say that this target is an API target. So we're going to provide the Swagger file. And we have two options. One of the options is just to file upload the schema file. The other option, which is what we're going to use, which is better, is basically pass the URL of the schema file so that Prodia basically will fetch a fresh version before each scan. We're going to click add. We have here an error because this target already exists on this account, but I want to add it anyway. And that's it. Okay. Now let's configure this target. So we're going to the settings. So the first thing we want to do is we want to make sure that Prodia authenticates on the API so that you can actually test those endpoints that require authentication, right? So the first thing we're going to do is we move to the authentication tab. We pass the login URL. So you can actually check here the login URL, which is this one here. Oops. Okay, so this is the login URL. And then we pass the authentication payload. So basically the credentials, which is this. Okay. And now we're going to click here on fetch. So basically what this is going to do is basically probably will make a call to this API endpoint with this payload. We made the request and we got the 3 fields that we already saw from the response. And what we want to do is we want to get this token field. So basically what we want to get is, let's look at the response here. I don't have here the response anymore. So basically from the response, we want to get the token, right? Value. And we want to place it in a header. It's going to be an authorization header. And then we're going to use as prefix bearer and save this. Okay. So right now, when you click scan, probably will first authenticate on this endpoint with this payload, and then it will fetch the value for the token field and will place it into a header, an authorization header with the prefix bearer and the token that it fetched. So it will make the subsequent requests with this authorization header. The other thing that I want to do here is I go back to the scanner. So this is the endpoint for the specification. I want to define a custom value for the API. So basically, I want to tell probably that for this farmer's ID that is used in a lot of different endpoints, I want to use actually a real farmer's ID. So I'm going to add here the name of the field. So farmer ID and the field value. I add it here and save. So basically when I hit scan now, probably will also, every time there's an input named farmer ID, it will use this value that I defined here. And I think we're ready. So now the next step is to basically click scan now and wait for probably to scan the target. In the meantime, we're going to add the exact same target, but we're going to use a Postman collection. So I have here Postman already open. I already imported, just to save some time, I already imported here the webship schema file, the specification. I just changed a few things here on this collection that I'm going to show you. So the first thing is, like for this collection, the authorization, I want to use a bearer token. And then the value for this token is defined in a variable that I defined. I created an environment with some variables that I can use for this collection. I'm going to show it to you. So this is the environment that I created. I already put a variable username with the username that we want to use. The same thing for the password. The token, which is the variable where we're going to store the token. The farmer ID, I want to put this farmer ID, the base URL of the API, and the token ID, which is the ID of the token, so that I can destroy a token that the API endpoint to destroy the token. I can have it a successful request as well. So then basically what I did was, so I duplicated this created token operation here because I want to create 2 tokens, one that I'm going to use to authenticate on all the other endpoints. And I also want to create a token so that I can use it on this operation, destroy token. So basically what I did here is making usage of the tests functionality, which is a piece of code, of script, of JavaScript that runs after making the call. So what I want to do is basically, like, you click send. So you're making the request. This was the response. So you get the ID, the token user ID. And what I'm saying here is that I'm getting the response, so this JSON response here, and I want to set the value of the variable that I defined token ID with the value of the ID from the response. So this is what this says. So after running this, like if we look here again at the variables, we see that the token ID has this value, which is the same as this one here. The other operation, create token, it's exactly the same thing, but in this case, I want to store the token itself. So I want to store the token because that token is used on the authorization, in this authorization that I showed here, right? So it's this variable. And then you can see here, like the get farmer. So it takes as input the farmer ID, which is a variable that we defined. Update farmer. I have some payload here to update the farm. Get farms as well, takes the input, the farmer ID, and so forth. And then here to add a ship to the farmer. So I have all the endpoints here configured. They are all using the authorization that I defined in the beginning. And if I click here on the collection and I click run, basically I'm going to execute this collection. So I'm going to make requests in the same order that I defined here with that logic to get the tokens and set values to the variables that the environment variables that I define and so forth. So when I click here, run ship, I can see that I had a successful response for each of the endpoints of this API, right? So now we need to export these Postman collection. So we're going to do that now. So export. Okay, so let's put it here. And since I'm using environments, I also need to export the environment variables. So this, unfortunately, Postman doesn't, like when you export a collection, it should export everything, the environment that you defined and the collection itself. But no, this is exported in different files. So you actually need to do some trick in order to set these values on Prodia. So you can click export here, and this is going to export the file as well, and that's it. Okay, so now we have the Postman collection file and we have the environment file as well. So we're going to go here, we're going to add another target, we're going to call it webship Postman, the URL of the API as well. And this is an API, it's a Postman, and I actually want to file upload this time. And I'm going to get the Postman collection here. Okay, add duplicate. Okay. And now I go to settings, and you see that you don't have the authorization tab anymore because that authorization, the authentication is performed on the Postman itself. We did all that and it's saved in the Postman collection. But you also see that you don't have the variables. So basically this is the trick that we need to perform now. So very quickly, on our GitHub page, on our public repo, we have a script. Under API scripts, you have a script that is called import Postman environment. That's pretty straightforward. So I'm going to execute that script. So this is this file here. Okay. I'm going to execute the script. So import Postman. Okay. I need to pass the target ID so I can get the target ID from here, from the URL. So this is the target ID here. And the Postman environment file. So basically, I'm going to pass this as a file name. Okay. Now, if I do reload, you're going to see that we have all the variables set here with the respective values, and that's it. So after this, it's the same. So I go to the target and I start the scan. And that's pretty much it. When we look at the coverage of the scan, and to finalize, we're a little behind on time. But when you look at like the previous scan, it actually hasn't finished yet. So if I go here to scan activity, click view, if I get the coverage file for these endpoints, and I do here CSV view, and this is endpoints. Okay, so you can see, like when you use the Swagger, probably also sends the authentication endpoint to be scanned and makes a request with bogus data. So that's why you have the 401. Then you have the authentication request here with the 200. So basically it created the token because it used the right parameters. For the deletion of the token, we only have these on the Postman collection. We are not able to do that with the schema file here because we need to pass as an argument a token that was created previously and it's still valid. And then the remaining operations are all 200. So all were successful. And that's pretty much it. Now we can move on to the Q&A. And Andre?
Absolutely. Well, thank you very much for that insight that you shared around why API security is important and necessary. We're going to open the floor to questions. I don't see any questions as of now. Still have quite a few attendees. So yeah, any parting thoughts you have, Nuno, for applying the API scanning and security?
I mean, it's just one easy step that can improve drastically the security of your API. We've seen in many scans, in many API scans, we've seen some high-risk vulnerabilities, and of course, by identifying them, it allows the developers to fix those vulnerabilities before getting to production, and that's of course very important. You don't want to be in the news for the wrong reason, right?
Absolutely, absolutely. Well, something that developers run into a lot is the expectation to complete a project and push out an update, and there may not be enough time to implement security. Where does Probly fall into that? How does Probly I guess add value and speed to the process?
Well, as you're developing the application or the API, as long as you have, or you can have a running application, then it's very easy to use a scanner like Probly. Just point it to the URL of the application or API. Basically, if you're scanning API, you just need to do the steps that I did here in the short demo. So it's pretty fast. Like in 5 minutes, you can configure an API. You can configure Probly to scan an API and kick off a scan, and then you just wait for the results.
Absolutely. And so with the results, if a vulnerability is identified, are there steps, remediation steps listed out?
Yes, definitely. So basically, for all vulnerabilities found, we include, of course, detailed description of what the vulnerability is and what the impact is. We include an evidence to prove that the vulnerability is real, so that you don't waste time validating the vulnerability. And it also includes instructions on how to fix that vulnerability. And those instructions, of course, are very valuable for developers so that they understand what they have to do in order to fix the vulnerability.
Absolutely. And we have another question. How will Probly fill values that I don't specify on the settings?
So if you're doing a scan based on the Swagger or OpenAPI schema file, you basically if your schema file includes examples, so you actually have that attribute example for each parameter. And if you fill in some examples, probably we'll use those examples as inputs.
Absolutely. Absolutely.
If not, I mean, it will use, if you say that in the schema file, if it says this parameter is a string, then we're going to use a random string like ABC. If it's integer, then we're going to use a number, and so on.
Fantastic. Any other questions out there, team? I'm not seeing any. Well, thank you so much for your time. I know it's late over there. Nuno is in Portugal, so really appreciate it. Any other no questions at this time? We will post this recording on the Probly LinkedIn page and give this access, the public access, and look forward to any other questions you may have about API scanning and security. Other than that, hope everybody enjoyed this webinar,